Welcome, welcome students. Once again, in the last video, I have shown you the activity and the temperature remains at 0 degrees Celsius until all the ice melts into the water and we are continuously heating it. My question is, on heating, why ice changes into water? On heating, why ice changes into water? Why? What is the reason behind it? We are going to do it, right? The question is, on heating, why the state changes from solid to liquid? In case of ice, why it changes from solid to liquid? What is the reason? So I have written the answer in the point form, right? On increasing the temperature, the kinetic energy due to motion of the particle increases. In the last video, I have 2 days earlier, I have discussed what is the kinetic energy. Energy means the motion of the particles, right? Every particles is in motion, right? On increasing the temperature, the kinetic energy of the particle increases because we are giving heat. The particles motion will increase. How it is going to increase? Because heat is giving there, right? On increasing the temperature, on increasing the heat, the kinetic energy due to motion of the particle increases. Due to this motion, due to this increase in the motion, kinetic energy, due to which the particle starts vibrate when and overcome the stronger force of attraction between the particles, because as you know, the solid has stronger force of attraction. When the heat is given, the particles of the solid are very close to each other. When we are going to hit, they are going to vibrate means vibrations. They are going to vibrate and they will slowly go apart from each other, right? The particles leave their fixed position and start moving freely. The particles of ice, that means the particle of ice start moving. A state will occur when the particles will be more separated from each other as compared to the solid, right? Solid particles are closer to each other, but in the liquid, particles are further from each other. Why they become further? Because when we going to give heat the particles, then they are going to start to vibrate, and due to vibration they are going to separate each other and breaks the intermolecular forces between them, and the state is called liquid, and they become so much far from each other that they form liquid. Because in solid the molecules are the particles are very close to each other, but in the liquid the particles are further from each other. So that is the reason why solid changes into liquid, right? Now one more question. The question is larger one, but you have to understand. In the experiment, the temperature of the system does not change, right? I have earlier told you the temperature remains 0 degree till all the solid ice changes into water. That means temperature remains same, the of the system does not change after the melting point reaches, till all the ice melts into the water. Even though we are supplying heat to the container, we are continuously supplying, but the temperature remains 0 degrees Celsius until all the ice does not change into water. जब तक सारा आइस पानी में नहीं बदलेगा, टेम्परेचर 0 डिग्री ही रहेगा. याद रख लीजिए इस चीज को, करेक्ट? 0 डिग्री ही रहेगा. वंस द all the ice changes into water, only after that temperature rises. एक बार सारी आइस वाटर में बदल जाए, उसके बाद आप हीट करोगे तो टेम्परेचर बढ़ेगा, तब बदलेगा, राइट? Now, the temperature rise above 0 degrees Celsius only after all the ice melts to liquid state. Only then temperature will rise. Before it, no increase in the temperature will take place. Why? Question is why there is no increase in the temperature until all the ice melts into the water. Only after when all ice changes into water, only after that the temperature increases. Why it is so? Where does the heat gone till all the ice melts to the liquid? Where the heat gone? Now let's see the answer of this question. Heat energy absorbed by ice without changing any raise in temperature. I have told you. Because why it is? Because this heat gets used up in changing the state by overcoming the force of attraction between the particles. So that means the heat is not used to increase the temperature. The heat is not being used to increase the temperature. It is used to change ice into liquid. It is used to break down, to overcome the force of attraction between the particles in ice, right? Understood? That heat is not being used to raise the temperature. That heat is used to break the force of attraction between the particles in the ice. This heat is considered that it gets hidden into the content. That means into the water. The heat which is being absorbed by the ice, that heat is not going to raise the temperature. That heat is going to be hidden or going inside the water molecule, right? Right? And is known as latent heat. This heat is known as latent heat. Dear student, please remember, latent heat does not raise the temperature. Latent heat does not raise the temperature. Latent heat changes the state from solid to liquid. Latent heat changes the state from solid to liquid, right? It does not increase the temperature. Understood? Now, what is the latent heat of fusion? Definition, a scientific definition is it. So, you cannot change this definition, right? Scientific definition. The amount of heat energy. What is latent heat? The amount of heat energy. The heat we are going to give here. How much heat? The amount of heat energy that is required to change 1 kg of a solid. That energy is required to change 1 kg of a solid into liquid at atmospheric pressure. 1 kg. Remember, 1 kg of ice has to be changed into water. 1 kg of ice, 1 kg of any solid changes into the liquid at atmospheric pressure. Again, atmospheric pressure means open utensil, you have to do it in the presence of atmosphere. At atmospheric pressure. At its melting point is known as latent heat of fusion. This known as latent heat of fusion. Fusion, again, the process from changing solid into liquid. Fusion is the process again changing from solid into liquid. At its melting point. At its melting point means 0 degrees Celsius of the water, and it should change from solid to liquid in the open utensil at their atmospheric pressure, right? And this latent heat is not increasing the temperature, it is only changing from solid to liquid. That is known as latent heat. It is also known as hidden heat. Hidden because it is going inside the water molecules, right? So this is one of the scientific definition of latent heat of fusion. You have to learn it in our exams. It will surely come in your test or in your exam, right? Now, two more important point. Particles of the water at 0 degree have more energy as compared to the particles in ice at the same temperature. At the same temperature means 0 degrees Celsius. At 0 degrees Celsius, water has more energy because water is absorbing the latent heat of fusion inside it. Latent heat of fusion. This heat is going inside the water molecule. So, water molecule has more temperature, but this latent heat of fusion is not present in the ice. Clear? Now, you have to learn also, only at 0 degrees Celsius water exists both as liquid and solid. Below 0 degrees Celsius, it will be ice, and above 0 degrees Celsius, it will be in the liquid form, water form. But at 0 degree, water and ice both can have same temperature, right? At 0 degrees Celsius, we can find liquid water, and at 0 degrees Celsius, we can find solid ice. Both this temperature at 0 degrees, right? So you can say melting point is that point, that temperature at which both solid and liquid can exist together. Always remember, above 0 degrees Celsius, there will be liquid water, and below 0 degrees Celsius, there will be solid ice, right? But at 0 degrees Celsius, both liquid and solid will exist together, right? I hope you have understood. Thank you very much.